One of the important topic in 8086 system bus architecture. The topic is coprocessor and multiprocessor configuration. The 8086 can be operated in two modes. One is minimum mode and another one is maximum mode. The maximum mode is provided to support the multiprocessor configuration. So usually the multiprocessor systems are referred to the use of multiple processors for executing the instructions simultaneously and to communicate with each other using mailboxes and semaphores. The maximum mode of 8086 is designed to implement three basic multiprocessor configuration. The first one is coprocessor configuration, in which the 8087 numerical data processor is connected with 8086 for specific operations. And the second one is closely coupled configuration, in which two independent processors like 8089 and 8086 are combined together for better output. And the third one is loosely coupled configuration or multibus configuration. So here we can have some independent processor or coprocessors to make the multiprocessor systems. First we will see coprocessor and closely coupled configuration. When we compare both the configurations, both are similar in many ways. In both the cases, 8086 and the external processor shares the memory, input-output system, bus and bus control logic, as well as the clock generator. So first we will see the coprocessor configuration. So this is the how the execution takes place in coprocessor can be explained in a simple diagram. Okay. The coprocessor cannot take control of the bus, it does everything through the CPU. When we are using the coprocessor configuration, the assembly language program is written in the superset of 8086, superset instruction of 8086 assembly language program. So if the coprocessor and 8086 are connected together, the coprocessor always wait for the escape instruction. Whenever the 8086 execute the escape instruction, then that instruction will wake up the coprocessor, and the coprocessor which is waiting for that instruction will deactivate the host test pin and execute the specified operation. So as I already told, the coprocessor will not fetch the instruction. The coprocessor will just execute the instruction which is fetched by 8086, the main processor. So after executing a list of specified operation, once it is executed, the execution of instructions was completed, then it will activate the test pin. During that time, the 8086 simply fetch the instruction and it just go through that instructions, and after getting the signal, then the 8086 will continue its own work. So this is about the thing what is happening in coprocessor, the flow of the execution in coprocessor configuration. Next we will see the closely coupled configuration. The difference between closely coupled configuration and the coprocessor is coprocessor, only the main processor will execute the instruction or fetch the instruction. The coprocessor will just get the data from 8086 and it will do the required sequence of operation. Okay. In closely coupled configuration, both 8086 and the independent processor can fetch the instruction and execute the instruction. That is the difference, main difference between this. So if you are replacing the block below with coprocessor, then that is coprocessor configuration. If you are replacing the block below block with independent processor, then that is closely coupled configuration. In both the cases, both uses common bus control logic, and common memory and common input output devices. And this is the execution taking place in closely coupled configuration. So if you see here, whenever the 8086 processor wake up the independent processor with out instruction, the independent processor will start to fetch the message and it will perform the required task. Once the task was over, then it will notify the CPU about the completion status. Okay, once it notifying the CPU about the completion status, it will make 8089 or the independent processor to wait for the request. Okay, during that time, the 8086 can independently execute its own instruction. Okay. So this is the advantage of having closely coupled along with the coprocessor configuration. So the closely coupled processor may take control of the bus independently, and the thing is that we cannot connect two 8086 in closely coupled configuration. Only one 8086 is allowed in closely coupled configuration. And the third one is loosely coupled configuration. So in loosely coupled configuration, we are having shared system bus, system memory, and system input output. But each processor has its own clock as well as its own memory, in addition to the access to the system resources. So we will have a common system resources. In addition to that, we are having separate clock for each processor as well as separate memory for each processor. So this kind of configuration used for medium to large multiprocessor systems. Each module is capable of being a bus master. Any module could be a processor capable of being a bus master, a coprocessor configuration, or a closely coupled configuration. So this loosely coupled configuration will have multiple configurations. So a coprocessor configuration may be a part of this loosely coupled configuration, as well as a closely coupled configuration also may be a part of this loosely coupled configuration. So the one of the main advantage in this loosely coupled configuration is no direct connections between the modules. So if there is any error or any failure in the module, the overall function will not be affected. Only the function belongs to that particular module will be affected, because there is no direct connections between the modules. And each share the system bus and communicate through shared resources. So processor in their separate modules can simultaneously access their private subsystem through their local buses. So there are local buses are also available, and that is used to communicate their private subsystems and perform their local data references, and instruction fetching is also happening independently. So this results in improved degree of concurrent processing. This configuration is excellent for real-time application, as separate modules can be assigned specialized tasks. So thank you.